again. Okay, I'm sure you're already excited to see the word quadratic in this.
No.
Okay.
Very much so.
So what is something quadratic? What does it look like?
It looks like Rachel. It looks like Y. It looks like Rachel.
What does a quadratic equation look like? You're all in big trouble if you cannot answer this question.
Y equals X plus
That's the formula to solve one. What does a quadratic equation look like?
Y equals X squared plus 17.
Just give me some numbers.
X squared plus 17x plus 17x minus 2.
Okay, yes. That's a quadratic equation. Why?
Because it is.
What's the highest power of the problem?
2.
2. It's quadratic if it's got the highest power of 2. Now, you all picked pretty rotten numbers there. This is not one that would solve by factoring nicely. You would definitely have to go to the formula in it. And the ones we're going to do today are going to factor. So let me provide one that's got a little sweeter numbers to go with. Suppose I gave you one like that. When we solve that by factoring, how do you know what power of x to put in your factors?
X and X is only 2.
Okay, she said x and x is only 2. What do you mean?
Because 1 plus 1 is 2.
Yeah, so the power is 1 and 1, f equals 2. How does the powers you write there relate to the power on the middle term? The middle term this is 3x to the first. These were x to the first. If you haven't noticed, you're always factoring with whatever the power on the middle term is. So whatever that middle term is, that's what you're taking, and then you find factors of 28, which would be something like 7 and 4 would be a good guess. And then, of course, you have to play with the signs to make it work out. We need a positive 3 in the middle, so we would need a plus 7 minus 4. And then, of course, you know that you solve it by setting the factors equal to 0. Not a big surprise. You've done that quite a bit, and you're going to do it a whole lot more before we're through this year. So that's how you solve a quadratic. This is called quadratic form. So it means equations that follow the same pattern, that look similar, or their powers, their exponents have similar forms. So I'm going to give you some examples here. If I gave you x to the fourth minus 5x squared plus 6 equals 0. Okay, that's an example of something in quadratic form. It follows the same pattern. On a regular quadratic, this first one, the middle power is x. How does the middle power relate to the first power? Half of it, isn't it? Okay, so this one over here that I just gave you, is the middle term, is the power half of the first term? Yeah, square is half of a fourth. This is far more exciting and more informative and interesting than shooting a paper wad into the trash can.
No projectiles.
Mrs. Myers. Mrs. Myers. That was a parabola right there.
Thank you. It was a quadratic.
So what are you yelling at me for?
Because you're not paying attention to this.
They were making sense
Okay.
of what you were
You guys have already solved a problem like that. How you can solve it by factoring, but instead of doing x and x, if you use the power on the middle term, you can factor with x squared and x squared. Okay, now factors of 6. It could be 6 and 1, or it could be 2 and 3.
Nope, it's 6 and 1.
The key thing is, will my signs be the same, or will my signs be different? Make a positive 6, both signs have to be the same.
Negative 3, negative 2.
Yes, it is going to be negative 3 and negative 2. Okay, and we could then set those equal to 0 and solve it. But my point is, you knew which power of x to factor with by whatever's on the middle term. So tell me if these things are in, actually let me write it out first. You'll know you're in quadratic form if the power on the middle term is half the power on the first term. And that's, you'll use that power, use the middle power to factor it. I'm running out of space here, though. Okay. So use the power on the middle term to factor. Okay. So now, tell me, yes or no, which of these are in quadratic form? If I gave you x to the sixth minus x to the third minus 2, is that in quadratic form? That's all I want to know.
No.
Is 3 half of 6? Yes, that's quadratic form. You can solve it by factoring. What power would you factor with? 3. So you factor with x cubed. What if I gave you x to the ninth minus 2x cubed minus 35?
It's a trick question, yes.
Is 3 half of 9?
No.
No.
Yes, it is.
Half?
Haha,
Yeah.
no. The other one was yes. No. No, she's gonna switch it up.
She's gonna make it no.
No. No. You got a minus yes, though. Yes.
Just learn how to do it instead of trying to guess.
Yes.
Is 1/3 half of 2/3?
Yes.
So, you can do this with the fraction powers. No, we're going to solve here in a minute. First I got you to be able to tell, you got to be able to tell. Okay, this is the challenge question of the day.
No, because he goes yes, no, yes, no.
Has nothing to do with it.
I'm telling you, it's no.
No.
Okay, what's the power on the middle term?
It's 1/3.
What is square root of x turned into a power? An exponent.
Oh, it is, yeah.
Isn't that 1 with an index of 2?
1/2.
That's a 1/2 power. So if that's a 1/2 power, is that half of the first power, which is a 1? Yes, it is.
That's what I said, yes.
So, yes, that's in quadratic form. You can solve it by factoring as well.
And then it's no, and then another one, and then yes, or no.
So now we're going to solve some of these little babies.
If you're gonna guess, you're gonna go A, B, C, D, A.
How does that even make sense?
What you gotta do, you're gonna guess.
B's not in there?
A, B, C, D, A, or A, B.
Oh, D.
Okay, so I gave you one with fifths. Is this quadratic form? I actually want you to solve this baby. So 1/5 is half of 2/5. You got a constant. So now you're going to go, yep, it's in quadratic form. I can factor this baby. What power do I use to factor it with? Whatever the middle power is, that's the one that's going to work. Because when I multiply b to the 1/5 times b to the 1/5, I'm going to add the exponents. And 1/5 plus 1/5 is 2/5. It works. Okay, the 6 you do like usual. I got votes for 3 and 2. And then I need to make a -1 technically in the middle.
So -3 and positive.
A -3 and a +2 in this instance since we have no numbers in front. Now, I actually want you to finish solving this one though. Once you've got the factors, what do you do with the thing?
Solve it.
Yep, you set them equal to 0. Tyler's right on that one. And then normally proceed to solve. You would add 3. Now, how do you get rid of a 1/5? There are 2 ways you can do this. I don't care which way, whichever makes more sense to your brain. The fastest way is to say, hey, to get rid of a 1/5, I'd have to take it, times it by 5, times the power by 5. But of course, if I do that to the left side, I got to do that to the right side. So the 5s would cancel, and I would be b equals whatever 3 to the 5th power is.
243. Got that.
3 to the 5th is 243.
Got that, man. It's the 1 times
power to a power.
Yeah.
It's the 1 times the 5.
Okay, now the other way you could do that, if that way didn't make sense, you could have, over here, b to the 1/5, you could have turned that into a, well, if it's going to let me write, into 5th root of b equals 3. How do you get rid of a 5th root?
Take it by 5.
You take it to the 5th power. It's still doing the same thing, whichever makes more sense to you. If it's in a 5th root, you get rid of it by taking it to a 5th power. Okay, are you done with this problem? We got to solve the other one. So, b to the 1/5 is going to equal -2 this time. I'm going to do what to it to get rid of the 1/5? Times my exponent by 5. I'm going to raise it to the 5th power. So then the 5's are going to cancel, and I'm going to have -32. Now, do I have to check this one?
I'm using my card. Yes.
Did you take it to an even power? A 2nd, 4th, 6th, 8th power? We took both sides to the 5th power. We took both sides to odd powers. You do not have to check it. You can if it floats your boat, but you're not required to. Only if it's an even power. You took both sides to an even power, would you have to check it. So, both of those answers are good. Well, this is not terribly painful. It looks sticky and strange. It's really not that bad. Okay, so one more just to make sure we've got the gist of it. How are we doing time-wise? Okay. X to the 4/3 minus 13x to the 2/3 plus 36 equals 0.
Third, you can do it.
Is 2/3 half of 4/3?
Yes.
Yes. So what power of x are you factoring with?
X to the 2/3.
You have to be the middle power, so we're doing 2/3. You getting all that there, Eric? Rogers, I'm sure you didn't get anything I said. Okay, factors of 36 to make 13. 4 and 9 do make 13, don't they?
Yes, and it's negative and negative.
Because since that's a plus, they both have to be the same sign, so yes, they would both be negatives, and -4 and -9 will go to -13. Okay, why is this one going to be a touch more fun to solve?
Because squared.
Okay, we have, this one was really nice. There's only a 1 on top that makes your life easier. This is not a 1 on top, so it's not a big deal. If I set that equal to 0, and I add the 4 over, okay, here's the big question. How do I get rid of the 2/3 power?
Square root first.
Now, we can put it in a root and solve it first, or we can just get rid of the 2/3 right now. That's what I do. That's, I think, the fastest way. If I want to get rid of the 2/3, multiply the exponent by 3/2. But, of course, I have to do it to both sides. Okay, because the left-hand side, everything cancels. So, okay, Matt just said do the square root of 4 dealy thing. The 2's on the outside, 4's on the cube is on the inside. Okay, which one should you do first? Do the outside first, it's easier. What's the square root of 4? 2. So you really just have 2 cubed or 8. And then you do it again for 9 this time. So we set the other factor equal to 0. I'm thinking this looks like it's going to be okay because 9's a nice perfect square number. I'm still going to get rid of 2/3 by taking it to the 3/2. And then I'm going to rewrite it back into the root so I can see what I'm doing. Eventually you'll get to the point where you'll just do these in your head. Wrong, you will show them on your paper. I said eventually. Yeah, because that square root of 9 is 3, and then the cube is still there, so it is indeed 27. Okay, did we take either side to an even power that we need to check?
No.
No, we did not. So once again, we have good answers. How many points are those worth?
Like 18.